Hey guys, today we're going to do how to name and write compounds with polyatomic ions. First off, what is a polyatomic ion? Exactly like the name says, it is an ion made of multiple ions, hence polyatomic, multiple atoms. Polyatomic ions are made of multiple atoms, but they act like one thing. As a result, sometimes you'll see them, and I don't think I wrote, nope. Oh, examples, sulfate, sulfite, phosphate, phosphite. These are just my real fast examples, but like they act as one thing. So SO4, like that's the one thing. And sometimes you'll see them in parentheses like that. Here's a cool fact, all but one. So every polyatomic ion is negative, but one. So you only have to know one that's negative. So what does that mean? The polyatomic ions will always be the second thing in the formula. The second thing in the formula. If they're negative, negative things are always written second. So how do I identify them from the names? Almost every polyatomic ion name ends in ate or ite, except for 5 that end in ide, and here they are: hydroxide, cyanide, peroxide, ferricyanide, ferrocyanide. Literally the only difference is the charge. And then your one positive is ammonium, which is NH4. I forgot to put my comma there. Okay, that's just really, really fast. But I'm not going to make you like memorize them or anything. Here's the list. And here, yesterday, we did the top ones, so polyatomic ions. Here they are. Acetate is written twice. Almost always we'll write it like that. So really, if you want to mark that one off, that's okay. But these are probably the most common. And actually, the ones that we're going to use all the time: nitrate, biphosphate, sulfate, like those are the most common carbonate. Those are like the most common. Those are what most of chemicals are made out of. Like, I guess there's probably a couple more, but we do use hydroxide a lot. How do you know from the formulas? If you see ate or ite, and then ide, but the ides, if you notice, except for oxide, like there's no such thing as hydroxium or ferricyanidum. Like they're different names than atoms. There's no just cyanidium or whatever. Polyatomic ions from formulas. You will always, always, always. So all the formulas we've done now have been two binary. They've been, two elements. Every single compound with a polyatomic ion, you will see more than two every time. And because most polyatomic ions are negative, it'll be a metal followed by 2 or more capital letters. Except for NH4, you just have to know when you see NH4, and it could be a nonmetal, or it could be NH4 and another polyatomic ion. So, but there will still always, always, always be more than 2 capital letters. Write the following names. So this is what you do. So funnily enough, like everything except for ammonium, so I might as well do that one first since I underlined them. Ammonium, there's your NH4. There's your one polyatomic ion. There's nothing different. The names, whatever the names are on this chart, that's their name. We don't change anything, no nothing. So, NH4, that is ammonium. So you just write the name down. Oops, there's supposed to be 2 M's. Ammonium. And then Br, that's bromide. Let's go to the top. So a metal, so there are 2 ions, followed by that. Now, I stuck this one in here because it goes back to yesterday's. If you have to look up, SO4 is a 2 minus. And this is a transition metal, so if that's a 2 minus, and there's no extra numbers here or outside of here, then that means it's a 2 plus. So this is iron, and then 2, and then SO4 is sulfate. Now these will take a little bit longer because now you have to, like, if you don't know you have to reference that in the periodic table and the back of the periodic table. So this is, it's super duper important to have this list. If you don't have it, you scroll all the way down in the Google Classroom, and it says periodic table to print is the name of it. It's the back. Okay, oh, back up. So go back. So again, a metal essentially followed by your polyatomic ion. So Ca, that's calcium. NO3, that is nitrate. Now, I can flip over here, but I know what they are. Except for this guy, because actually I know what he is. And again, oops, wrong way. SCN. I'm going to name that guy first because, oh, thiocyanate. So, it's got a 2 outside of it, and chromium is a transition metal, so if there's a 2 over here, that means it's a 2+. So the other dead giveaway, because they act like one thing, that's why there's parentheses, but so like if there's a number on the outside, that's automatically going to be the charge of the transition metal. So this is chromium, and then thiocyanate. I think I spelled that right. Cyanate. THIOCYA. Yep. Oh, I forgot the 2. And okay, if you have to add a Roman numeral in like that, whatever. Strontium phosphate, like strontium phosphate.
Mama, I need your help.
Hold on. Okay, so dead giveaway. Anytime you see parentheses, that's the polyatomic ion. Isn't that awesome? So barium, just like before, you just name the 2 parts. Barium, and then OH is hydroxide. Hopefully that's not too hard. It's the exact same steps that we've seriously been doing. Like, the whole time. You just name the 2 bits. That's all naming is. That's it. Okay. There's a chart again just so I can flip back and forth really fast. Now, again, sort of tricky writing the formulas, but they're ions. They are an ionic compound. So every single time you have an ionic compound, you have to look at charges and switch them. It's a must. And, again, tomorrow is the last naming rule. Still have to look at charges. Okay, so what does this mean? The 4, tin 4 phosphate. That 4 means tin is a 4+. And phosphate, again, you might have to look back at the chart, but phosphate 3-. So 3-. So what does that mean when you write the formula? So they are not the same charge. So that means when I write the formula, this guy needs parentheses around him. And you keep it the same. Like, you don't ever change those subscripts. You just add parentheses and put them on the outside. So, tin is SN. And then that 3 is going to go with the tin. And then phosphate. And so I know I have to put a number. You just write PO4 because that's what phosphate is. And then you put another 4 on the outside. These are all polyatomic ion ones. Ammonium carbonate. Ammonium. Here's the 1 positive polyatomic ion. That's a +1. Carbonate is a... I always forget this one for some strange reason. Carbonate. CO3 2-. So, I mean, if you want to write, NH4 and CO3 2- just to help you, that's fine, but you don't have to. You have the table, you have everything. So, okay, so, but charges are opposite, right? They're not the same. 2-, 1+. So, where does that 2 go? On the outside of that whole thing. So, NH4 parentheses 2, and then carbonate, there's a 1 that you don't need parentheses around him because you don't put anything extra. CO3. What happens if you don't put parentheses around NH2? That formula is NH42CO3. There's not 42 hydrogens in there. There's 2 NH4s. They act like one group. Like, so, like, you just messed up the formula horribly by not putting parentheses around them. 42 hydrogens. That's crazy. Okay, calcium acetate. Calcium 2+. Acetate is this weird one down here. Okay, so if you can't tell what the charge is, you just look there. There's no number, so it's a 1-. So again, switch the charges, but you don't write 1s. Calcium, and then acetate is C2H3O2 but it's a 2, so I put it in parentheses and stick a 2 on the outside. Lead 2 silicate. Okay, so here's the funny thing. I tried to put ones that we don't normally see on the examples, so it's not like silicate's going to be one of your answers. So I actually don't know what his charge is. I think it might be a 2, but you never know. Lead 2 means that's got a 2 plus. Silicate is, oh, there we go. It is a 2 minus, but I thought it was O4 instead of O3. So, oops, wrong way. So silicate's a 2 minus, no extra numbers. You just put PB for lead, and then silicate was SiO3. No parentheses, no nothing. You don't put parentheses if you don't put any extra numbers. Calcium bicarbonate, this is a 2 plus, bicarbonate's a 1 minus. Let me double check. But I'm pretty sure bicarbonate. Or I could be wrong, and it's a 2. Bicarbonate. Oh, here we go. It's a 1. HCO3. So bicarbonate is a 1. So Ca, and then the 2 is going to have to go on the outside of the HCO3. 2. Potassium, 1 plus. Now this looks like it might be it's got the di, it's got a prefix, but you can't be thrown off by that. Like, that's a metal, so it's an ionic compound. You just have to know dichromate's the only polyatomic ion that's got a prefix in it, so it's this guy, and he's a 2 minus. So potassium is just K, the 2 goes with it, dichromate is Cr2O7, right? Cr2O7. I'm gonna erase that. Okay, and then barium iodide. Oh, that guy snuck in. I think I was gonna do iodite. Yeah. Okay, I'm changing it. Change that to a T. Iodite. There are no ites on here. Barium is a 2 plus. Iodite is a iodate. Oh man, there's no such thing as iodite. Okay, well, then we're going to change the whole name. Iodate. But he is a iodate. 1 minus. 1 minus. So Ba, and then IO3 with a 2. Yep. And then potassium permanganate, that's a 1 plus, that's a 1 minus, and if you need to look, permanganate is, oh, no, yep, MnO4. So KMnO4. Okay, so that seems like a lot of examples, but I wanted to show you a bunch of different things. Use the list, like you don't have to memorize these things. Good luck. I think I'm just going to do, I might do one combining everything, but it's only going to be like 5 questions. So there's a full polyatomic naming, polyatomic writing formulas, and a couple everything mixed in. So hopefully you're doing okay with those. So good luck.